Hey, I'm Skipper. I lead the R&D, data science R&D department at Civis Analytics.
I'm Lori. I am a senior product manager at Civis Analytics working on our data science platform.
Thanks everybody for sticking around Friday at 5. I hope this is entertaining for y'all. So what we're going to talk about today is kind of our story at Civis. It's a little different than some of the talks that we've heard so far today. It's not going to be super technical. It's going to be a little more of an applications talk. So it's basically how we use Jupyter to do our work and how we use Jupyter in our software product. So we're going to talk about where we came from, the type of work that we do, how we use notebooks to get it done, and the points where we actually don't use notebooks and why. And we're going to highlight some of the lessons that we've learned kind of the hard way, hoping that some of y'all may not have to learn these lessons yourself the hard way. Kind of along the way, as we've matured as an organization, we've been around about 4 years. We've really become data-driven ourselves and worked with a lot of organizations to help them become more data-driven. And we're going to talk about the processes around that. There's some technical solutions at the heart of this, with centered around Jupyter, but there's also a lot of technical solutions that don't have much to do with Jupyter, and then there's a whole lot of a process that goes into making effective data-driven teams. And we're going to talk about it from two perspectives. I'm going to talk about it from the data science perspective. Lori's going to talk about it from kind of the product and technology perspective. So if the end is data-driven teams and organizations, we posit that the beginning is Jupyter Notebooks. This shouldn't be a hard sell here at JupyterCon. So the next point is a little odd. We didn't start with Jupyter Notebooks. We didn't start in our platform with Jupyter Notebooks, and we're going to talk a little bit about why. So first, let's set a little bit of context for who we are. We're from Civis Analytics. We got our start out of the 2012 Obama re-election campaign. So 5 years ago, I say we, I didn't actually work on the campaign, but I'm going to say we. We ran the first individualized presidential campaign in history. Working as data scientists in that environment is not totally different than the work that we all do today. It was time-bound, high pressure, a bunch of really smart, driven people working together kind of towards a shared goal. And using data and data science to understand and influence people, understand why people make decisions and help influence them. And along the way, we built a data science platform to help enable our data scientists to do this work. There was a lot of stuff that they were doing that they didn't necessarily need to be doing. So try to make them more efficient in their work as data scientists, enable them with software. So after the election, we realized that there's a lot of organizations across the country that want to understand and influence people. They want to understand people's behavior and measure it and influence it. So we started out as a data science consultancy. And we also realized that the enabling technology that we have to do the consulting work was a product in and of itself. There's a lot of people that want to be doing what we're doing. So we continued to build on the data science platform as we provided our solutions. And now that's a core product of Civis as well. So there's a few keys, we think, to effective data-driven teams. This is kind of front and center, the lessons that we've learned. We certainly didn't start here. We learned a lot of these lessons the hard way. We kind of knew that these were the shared ideals about what makes a data science team effective. But we weren't quite sure how to do it and how to get it done. And we're going to talk a little bit about how we learned these lessons. So there's two main components, I think, to effective data science teams. First, you have to build trust. And then second, you need to be a really efficient team. So the first question is, trust with whom? There's a few different answers to that. I think the first and probably most important answer is with your business stakeholders. The people in the company that want to be data-driven and want to use data to make decisions. We all, I think, tend to take for granted that people want to use data to make decisions and want to be scientific about their decision-making process. That is not the case. There's still a lot of selling to do. There's a lot of inertia, and it's how can we help build trust with them and towards the data science teams so they can understand how they can use them in their organization. There's also trust between the data scientists and the IT departments. I'm going to talk a little bit more about that because that may not be super clear why. And then there's trust within your data science team. So you want your team to be very tightly integrated and trust each other and work well together. And we're going to talk about a little bit about how we use Jupyter Notebooks to enable that kind of trust. And then once you have an organization that trusts your data science team and they're kind of sold on the entire premise, you need to build an efficient data science team. So efficient within the team and then allowing the team to actually influence the business and provide efficiencies for the business. So again, this is not where we started. We didn't start out as a well-oiled machine like this, but we're moving in that direction. Okay, as part of building trust and building efficiency, there's two further aspects, right? So there's some technical aspects, which a lot of us probably already understand, but we're going to talk about a little bit more. And then there's a huge social component to this. The technical problems are often, as technologists, easier for us to solve, I think, but the social problems are no less important. So technical aspects of trust building, first is security. This has been first and foremost for everything that we do. We work a lot with personally identifiable information and private health information. And it's absolutely paramount that that data stays secure for your customers and for your business. So everything that we've built around Jupyter Notebooks and our platform has been security first. For the data science teams, you need to ensure that all of your work is repeatable and you don't need to think about it. Like when I hand off code to someone on my team or when a junior data scientist hands off code to me, I want it to just work. So we want to have a shared environment, and we want to build that trust between us that when they hand me code, I'm not going to have to set up a new development environment. We all kind of work the same way. It makes for tighter, faster teams. And then the social aspects. So correctness of code and methods. When I get code from someone else, I want to know that it's the right thing to do. That's often difficult, but Jupyter Notebooks help us a lot with that. We'll talk some more about that. The stakeholders also want to know that what you're doing is the right thing to do. So they want to be able to see the work that you've done, and that's this aspect of transparency at the end. So the first thing, when you show anybody any kind of result, the first thing they ask is, where did this number come from? How did you arrive at this conclusion? So you want everything that you do to be fully transparent, from the ETL to the modeling to the deliverable, and then the deliverable. So it's very, very important that data science teams demonstrate incremental value to the stakeholders and to the business. I think this is sometimes lost on a lot of data scientists. I think we're still kind of trying to figure this out. Organizations are trying to figure out how to get information from their data science teams. So we often hear, I have a team of 5 data scientists. They've been working for 6 months. I'm not quite sure what they're doing. So it's very important to be connected back to the business and delivering incremental value and showing value to the stakeholders. And we'll see a little bit about how we use Jupyter to do this. So now, to be an efficient data science team, this is no less important. There's a few aspects of this. First is scalability. Your data science teams need to be able to scale up and scale out without too much hassle. So if they need a bigger machine, they should be able to get it. If they need a lot of machines, they should be able to get them and use them easily. Automation. So there's 2 aspects to automation. One is schedulability. When I need code to run, and I need to be confident that it's going to run, and I need it to deliver its results. I need it to fail on retry. I don't want to stay up all night babysitting this code. And then there's also this concept of automation that we call build once and build well. There's some aspects of data science that you probably find yourself doing every time you start a new project. You write the same 200 lines of code. For us, it was using a model to predict at the national level over and over again. So we probably had 6 different implementations of that. This is an example of something that we could just build once and well, and then everyone can use it. And then deployment. Deployment is something that a data science team probably shouldn't have to think too much about. As we're delivering value to the stakeholders, we want to go from a Jupyter Notebook, from a prototype, to in the hands of someone else without a ton of thought or a ton of effort on our part. And then finally, the social aspects. The social aspects of increasing efficiency. The main takeaway here is we want to go from tacit knowledge to explicit knowledge. So it's great if someone on your team is like very, very smart and a very good problem solver and can figure out the best way to do something. But if that knowledge just stays with that person, then it doesn't help the organization and it doesn't help the team. So we need to be able to share all of our knowledge. It needs to be organized. I need to know where your work is. I need to look at it. I want to be able to do that quickly. It should always be in the same place. People should be working collaboratively anyway, so you should be, as you're doing the creative part of a data science project, your team should be working together, and then all this work should be easy to find. And these are things that we struggled immensely with. And we'll talk a little bit about some of that. So now I want to tell you a little bit about the early days of Civis. So this is a project that we did about 3 years ago now, kind of exemplary of the work that we do and how we work and some of the challenges that we faced and why we made some of the choices that we did. So we worked with a national health insurance nonprofit to try to get people to sign up for healthcare. So when the Affordable Care Act passed, there were 40 million Americans that didn't have insurance. There were 40 million Americans that had to get insurance. So the goal of this nonprofit was to enroll as many Americans as possible through the private exchanges or other public assistance programs. So what are the challenges that we face? There's no list of everyone in the country that doesn't have insurance. Different people have a different likelihood to have insurance because of who they are, where they live maybe. And a lot of people really just didn't like the policy. So there was a lot of challenges that we had to overcome. So our solution, we figured out who didn't have insurance by building a model on a subset of people and then predicting for all Americans the likelihood whether or not you had insurance, and also trying to understand the best way to reach out to you and the messages to give you to get you to sign up for insurance. And then we proceeded to do the direct outreach via TV, digital messaging, et cetera. So what were the actual technical challenges that we had to overcome here? First, we had to get data about everyone. So we had to have a database of all adult Americans. Second, we needed to take a representative sample from that data set. And then we needed to call all those people and ask them, do you have insurance? Telephones aren't the only way that we run surveys, but it's good enough for our purposes here. Then we had to build a model on those people, whoever responded to the survey, whether or not you had insurance, and then we could use that to predict on everyone else the likelihood that they had insurance. And then you cut a list of people that are most likely to not have insurance, and then reach out to them through targeted messaging. And the messages themselves also went through a statistically rigorous process to make sure that these messages actually had a positive effect on people's likelihood to sign up for insurance. So those were the technical challenges. The technical solutions were wrapped up in our data science platform. So the platform was kind of optimized to solve these kinds of problems. As we did this work, there was a lot that happened in Jupyter notebooks, but the Jupyter notebooks were on people's laptops. They weren't in our platform, right? So the first challenge was data. We had to get this database of 220 million Americans. So we have a consumer database of Americans, and we maintain and curate that. Our data scientists needed access to the data, so they needed access to the survey data, which is in a different place than the consumer data. Our clients need access to their databases all in the same place. Data enhancements. So we have the survey data. We need to match the survey respondents to our consumer data file. So we came up with a way to do probabilistic matching, and that's one of the examples of something that we built once and built well. We didn't want to do that again. We also append data using our survey data to the consumer data file to enhance it and make sure that we have features that are very predictive for the types of problems that we were trying to solve. All these data scientists worked in SQL. SQL turns out is a really good engine for manipulating data. It's been around for a little while. And then scheduled container orchestration. So what does this mean? So this was just this common runtime environment that our data scientists could use to execute the code that they've already written. So not to do the creative ideation part, but once you come up with a solution, to run it. Either run it on a machine, like a large machine, or run on multiple machines without having to think about it. And we use containers and Docker to do that. And then reporting via BI tools. A lot of these data scientists were used to working with something like Tableau. So we allowed them to work in Tableau. And then we built all this around what we call a data science API. So the things that we built once and built well, we wanted people to be able to use through a RESTful API. So you don't have to like go in and when you want to and use the GUI when you want to just orchestrate a workflow or something like that. So all of the fun work happened in Jupyter notebooks, but they were on people's machines. They were on their laptops or maybe on an EC2 instance. So not fully connected. And you can already kind of see, if you think back to what we think an efficient data science team looks like, where we're falling short. So, because it sounds like we solved a lot of the problems, right? So what are the problems that we have left? So first, a bit about my progression as a data scientist. I think this will help show some of the pain points that Jupyter will solve for us. So I have a background in econometrics. I've worked in the Python world doing statistical modeling for the last 10 years or so. I was hired to do kind of causal inference in the face of sparsity and high dimensionality. What in the world does this mean? So we need to make causal inferences about something, say like these messages that we were giving to people to see whether or not they had an effect. The problem is we have little to no theory to guide us, so we don't have a theoretical model of how this would work, and we have a ton of data. So if we're going to use something like tree ensembles or the lasso to help us understand the best predictive models, but we also want to make causal inference, like all traditional statistics is out the door. So I spent my first year, me and my team, kind of working on this problem. We came up with some implementations in software of some of the kind of state-of-the-art algorithms, and we put them in white papers. We gave brown bags to the company. We made sure that people working very closely with the clients had access to this. We did this all in Jupyter notebooks, but they lived in GitHub or Box, and if anybody needed to really use these methods, they had to come over and grab me or somebody from my team to work through some of these solutions. So the corollary to this, while I was working on these problems, I also had to solve what I call the hashtag DevOps for data science problem. This has been a thorn in my side and probably a few people here's side, I can imagine. So while we were doing this work, like the health insurance work, we started to come up with new challenges, new clients, bigger data sets, new methods, and people just couldn't do their work on their laptops anymore. And our systems team spends their time making sure that the application runs. So they're not supporting ad hoc requests for people who need to provision a new instance, new EC2 instance in AWS to do work. So I put on a new hat, which is, I guess, part of the data science progression. And I learned how to use EC2. And then my systems team said that the internet's really scary, be careful out there, you should do all your work in a virtual private cloud. So I had to learn AWS VPCs, how to use virtual private clouds, and how networking in AWS works. Learned a lot about S3, learned a lot about the CAP theorem the hard way. And then my systems people told me I was crazy. Why are you doing all this in the AWS console? We follow a thing called infrastructure as code. You can write all this down in this YAML language called CloudFormation, run in AWS. That's how we deal with all of our work. I was like, okay, I think I'm becoming a systems engineer slowly. And they go, oh wait, but you should use Ansible to do that. If it lives in an Ansible playbook, then it exists in the world. That's how you keep up with all this stuff. I was like, okay, that's helpful, thanks. Oh yeah, we're also using containers. So you shouldn't run all this stuff on raw EC2 instances. Stop making AMIs, stop doing all of that, use Docker. Like, okay, so I've got all these Docker containers now. I needed a way to give them out to the world, right? I needed a way to do container orchestration. Our engineering team uses Kubernetes, so I had to learn a lot about Kubernetes. Maybe see where this is going. Kubernetes didn't do exactly everything that we needed it to do. A lot of our systems code is written in Go, so I had to go out and learn some Go. I learned enough to read the code and do code review for the people that know what they're doing, but I'm by no means an expert in this. And then where every data scientist finishes their transformation into a true data scientist, I ended up writing a lot of JavaScript, which is probably a tale for another time. But the challenge here is probably pretty evident. I'm pretty far afield from actual data science work, but we were supporting the company. Because meanwhile, we got bigger. So we started with about 13 people, and now we're about 150. And this became very, very challenging for us. So scaling is not just a technical problem, but also a process problem. And it was time for us to grow up. We still wanted to deliver solutions that were of like the highest quality, but we had to fix our processes, and we had to fix the way that we all work together, so that I'm not doing like ad hoc systems work, and all of the insights that we're coming up with and delivering are not living on our notebooks, on our laptops and notebooks. So we had automated a lot, encapsulated a lot of these lessons in software, but we hadn't figured everything out. So kind of Jupyter was the next critical piece that we needed to add, but we weren't really sure how to do it. And I left this one up to the experts, as opposed to like kind of the systems R&D work. And this is where Laurie comes in as a product manager for how to figure out like the best way to enable like effective data-driven teams. We know what they look like, we know how we work, we know how we want to work, but like how can we use Jupyter given the rest of the work that we've put in? And Laurie's going to tell us about what we've learned. Before I hand it over to her, I just want to introduce kind of this project that we're going to build around. This is kind of a typical project that a user of our platform may do, or a project that we may do for them. So the company here, the example is a food delivery company, and they're in their growth stage and they want to acquire more customers. So what does a project like this look like for us? They come to us with a list of their customers. They do ETL on this data, then match it with our consumer data file, build a model to understand like deeply what these people look like, and then do outreach to either get more customers that look like the people they have, or if they want to diversify their customer base, maybe find customers that look different than what they have. And with that, I'll turn it over to Laurie.
Great, thank you. So yeah, I am a product manager for Civis Platform, and I hear Skipper talking about all of these horrible DevOps things he needed to do, and I think that's an opportunity. I see that as a place that I can help. So, I mean, data science teams everywhere are growing and evolving. We were pretty sure that what we encountered at Civis was not unique. So we wanted to verify these ideas outside of our own walls. Our product team spoke to a few dozen data scientists across a variety of industries, and it turns out the same issues, the same workarounds keep popping up. We knew we were pointing in the right direction. We did notice that by hosting Jupyter notebooks inside of our Civis data science platform, we would be able to accelerate the way our team could evolve into a disciplined data science organization. And as Skipper mentioned earlier, we believe that the core pieces to becoming a mature data science team really revolve around building trust and building efficiency inside that organization. So let's talk a little bit about building trust. There are technical aspects to building trust, and it really starts with security. Building trust for your data science team means taking security very seriously. The way our team solved for trust and security was to obtain SOC 2 Type 2 compliance for our Civis platform, and we're on our way to HIPAA compliance as well. The great side effect of having a compliant data science platform is that when we moved Jupyter notebooks into our platform, the people who had previously been working in local notebooks were able to move their exploratory work off of their laptops and into the platform. So this means they're now exploring their data in a known environment with known security. And because the Civis platform environment is tightly coupled with our data science API, our notebooks users have less risk of accidentally exposing an API key or moving data to an insecure location. We gave a talk at PyData Seattle last month that gave more specifics about our security implementation for how we integrated Jupyter notebooks in the platform, and you can find that on YouTube. The other part of trust is repeatability. We tackle the trust and repeatability through package management, transparent environments, and Docker containers. So your colleagues on your data science team need to know that the code you hand them is going to work. What we've done is that the environments where your notebooks are running are always going to be the same because the package requirements are stored in a Docker container. Anyone who runs a notebook runs it using the same Docker image specified for that specific notebook. So people running a notebook across the team all get the same results. The other type of trust that's going to be important for a mature data science team is that social trust. Your stakeholders need to trust your results, and your teammates have to trust your methods. We know that Jupyter is an amazing tool for adding context to code. And as we grew, we increasingly encouraged a culture of showing your work and good documentation practices during the exploration. Jupyter's really been crucial to ensuring that data science teammates can validate each other's code correctness and build trust in each other's work. The other part of trusting your teammates is providing transparency. In a disciplined data science team, all the code is going to be transparent and auditable. And for example here, this is an ETL example. This ETL code is version controlled in GitHub, and it's available for all of the other project members to see. So just like trusting your peers, earning your trust from your stakeholders is going to be extremely important to be a mature data science organization. We think that a really great way to demonstrate value is with usable visualization that the less technical person can easily digest. This could be provided in a Jupyter dashboard, or a Shiny or Bokeh, or as in this example, this is a JavaScript web app that we have built. Our data science team uses these tools to deliver incremental value to our decision makers. And we think that in turn does build trust for the work that the data science team is doing over time. So alongside trust, we want to make sure we're building efficiency with our data science teams. A disciplined data science team really requires this efficiency, and we think that Jupyter has been a really important part of building that at Civis Analytics. All right, so the technical side of building efficiency starts with scalability. With notebooks and Jupyter, we can scale up and we can scale out. For scaling up, we can ask for more runtime resources. We can increase memory and CPU for the notebook to support more complex computation requirements. For scaling out, you can see here, just with these few lines of code, we can train a scikit-learn model and score a national level model in parallel. Our machine learning toolkit will automatically provision and deprovision the optimal number of compute resources without any user intervention. And here, none of the processing is done actually in the notebook. Our built-in seamless integration between Jupyter Notebooks and the Civis Data Science API allows us to run all of our machine learning in the cloud. So the other way to build efficiency is obviously going to be through automation. So often in data science, your work has to be replicated on a regular basis. As Skipper mentioned earlier, we'd already built in the tools to Civis platform that allow our data scientists to automate their work and increase our team's efficiency. Since so much of our work revolves around Jupyter Notebooks, we really wanted to be able to incorporate our notebooks work also into our automation paradigm. So, you can see here on the right side of the toolbar, of the notebooks toolbar, there's a play button. So using that play button, our users can actually deploy this notebooks file into a script that runs on a schedule. These scripts can be scheduled at a certain time of day. They can be added to job chains and added to workflows to be put in a whole packaged piece of work that's run on the schedule, and you can just set it and move on to the next work. In this case, it allows a data scientist to retrain and then make these scores available for production. Data scientists using our Civis platform can easily jump from notebooks exploration right into a production-ready script, and then they can just automate that script and move on to the next task. We're increasing efficiency by streamlining that process between exploration and automation and deployment. So team efficiency is also an inherently social problem. As our data science team grew, we needed to incorporate tools into our product that encourage data scientists to just use more efficient best practices. We encourage data scientists, this is the project we saw earlier. We do encourage data scientists to keep their work organized in these projects. It's a really easy way to hold that full set of work associated with your project. You can keep your notebooks, your scripts, tables, reports. Add some markdown on the right side there to add some context. We think we've given our data scientists this tool to help them stay organized within our platform and be able to work together better. Collaboration, I think, this is really what it all comes down to. Bringing discipline to your data science team is just encouraging collaboration. As your organization grows, the teams form, and they really just need a better way to work together. If your work environment naturally facilitates sharing and collaboration, it's really easy to make that cultural shift with your team's operations. Civis platform includes sharing functions across all work done by our team. By building this into our work environment, we've increased transparency and visibility across all of the jobs that we do, and we've also just facilitated that communication amongst the team. So now with Jupyter Notebooks as an element inside of this shared environment, we have an even more seamless way to communicate with each other. We can easily debug and replicate work done by our teammates, and it's just a lot easier to get started on a project without having to recreate the wheel. What this really comes down to is knowledge sharing. We've learned that we really have to be deliberate about the way that we share our knowledge, and we think Jupyter Notebooks are extremely enabling for this. The shared access to Jupyter Notebooks inside of our platform means that we can find the best way to solve a problem, document it alongside the code inside of a notebook, and then leave it in platform for the rest of the team to find. The rest of the team can then learn the best practices for data science. This is great not only for onboarding new team members, but it also just ensures that the entire team has access and understands how to learn use these methods and use these tools, and it's going to give them the best results. What it does is it makes all of our data scientists as good as the smartest person on the team. So finally, really, this is the other side of the collaboration piece of this is discoverability, as Skipper was mentioning earlier. This goes right alongside with documentation. What's the point of building out your best solutions and recording them if nobody can find them? We really address this by making sure we include metadata and descriptions along with each piece of the objects inside of our platform. So they're really easy to find using our search. Socially, there's a bit of a challenge. You have to encourage your teammates to name things properly and actually use the tools that we give them. But we think that this is where that cultural shift of becoming a disciplined data science organization is really coming. We offer these discoverability tools, and the tools that we've incorporated into our product are really designed to help push that cultural change towards being a mature data science organization. And I'm going to hand it back to Skipper.
Yeah, just to wrap up a little bit. So I think we're at a little bit of a crossroads in terms of data science. Like if you're on Twitter, like you've seen people talking recently about how machine learning is just the 10% of what you have to do as a data scientist to actually get your data, get a result, and then have any effect and any impact and make any change within an organization. And Jupyter is certainly helpful with that. It's certainly helpful with the creative process. It's helpful in knowledge sharing, but it's not everything yet. So I kind of hope you've maybe understood a little bit of the pain points that I've talked about, and that some of this is hit home with maybe we have to go beyond Jupyter a little bit to solve some of these problems. And some of these problems are very hard, frankly. This took us a very long time to figure out kind of the best way to work. And I guess I just want to end on one note, the same note I think that Fernando and Peter started JupyterCon on, was just this note of sustainability. And I want to add kind of a thing about corporate responsibility to this. So the whole reason I'm here and doing this and know anything about Jupyter Notebooks and how to do this is because I cut my teeth in the open source world, learning from the entire community, building tools that are now used everywhere and in other companies. And I did this mostly through the kindness of others. I spent a long time in graduate school working on this stuff. And I was able to go to PyData conferences or conferences like JupyterCon through sponsorships. And companies and foundations like NumFocus enable kind of the next generation of open source developers to continue to sustain the ecosystem. So I kind of encourage you, if you use these projects at work, talk to your employer and talk to them about donating to NumFocus so that you can continue to do this work. It's cheaper than SaaS, I promise. But yeah, thank you. I think we have a couple minutes for questions. Yeah. Yep.
I like your idea of showing incremental value to stakeholders and from the ETL modeling to deliverables. Oftentimes, the analytics function is located within the finance or marketing department of big companies, and the infrastructure or IT departments, they don't necessarily talk. How do you suggest that we bridge this gap?
So the question is how to bridge the gap within an organization between the people in different business units like finance and marketing and the IT department, because they're often the gatekeepers of the data. That's the question, right? And if I have any advice about that, I mean, I think the building of trust is the kind of the most important part. And so one of the ways that we've done this is when we have to kind of bridge this gap within an organization is make sure that the ETL process is handled on the IT side, or signed off, at least signed off on the IT side. So you have access to this data, you're going to get it in this way, that's okay, and then you have like a materialized view of the data that you need to do your work. So you don't need access to the entire organization's data, you just need access to a subset of it, and you have to bring both people to the table and have them agree that this is the handoff point, this is where that code lives, it's versioned and auditable, and then hopefully they say okay. Yeah. So access to what sort of thing?
Any sort of data science or analysis.
How to get started?
Yeah.
So Jupyter notebooks. Like I think that is actually the beginning. So the question was about how to start a fledgling data science team in an organization. Is this an existing organization or a new organization?
The organization exists and it's full of people that's pretty do everything already.
Don't get it right. So how to like show and build a data science team within an organization that like hasn't embraced these methods. Start small. Work together and like get an early win. So it's part of this like trust building exercise. The way that I like to approach it and we like to approach it as an organization is like, I want to show stakeholders something they already believed, backed up by data, and I want to show them something new. So confirm a bias and change someone's mind. I think that's the way that I approach it. Yeah.
I'm in sort of a similar situation where big company, 2 data scientists, and trying to build trust but also increase efficiency. What we run into is, are you trying to take my job away? And what's your advice on dealing with that kind of pushback?
So the question was dealing with pushback from, are you trying to take my job away? And I hope the answer to that is we're not trying to take your job away. We're trying to take away or maybe automate the parts that you shouldn't be doing anyway. We're trying to free up your time.
Yeah, it's enabling you to do more things.
So like I talked to someone in an organization that I think probably had this worry too. And I asked, okay, well, what do your results look like now? How do you validate your results now? And he said, oh, I don't have time to do all that. I'm dealing with all these incoming emails and we're orchestrating workflows through emails and I have to wait on this from this person. I have to wait on this from this person. And it was kind of like, well, I'm certainly not going to, like, maybe I am going to take that away from you. But I'm going to give you back your time to like solve the problems that you need to be solving, the creative problems.
What's your product? What do you offer in your product? Because obviously there is need for like data science management type of product. There are like so many vendors just in that floor, right? So what's unique? Like, what do you offer?
Sure. So the question was kind of what's unique about our product, and I think I have 2 answers to that. One is the data. So our platform actually comes with this curated data set. We've like brought together like vendor data, third-party data, publicly available data, and I sometimes like to say it's kind of ETL as a service, but it goes beyond that. But if you've ever tried to amass this kind of data, you know how like dirty and hard that problem is. So we've kind of done that, but we've also QC'd this data. We make sure that it is good, make sure that it's correct. We catch errors in it, and then we add value by appending like model data to that. So we've
Data expensive too.
the data. Well, it's cheaper if you get it relicensed. Yes. And I think so that's one of the value adds that we have. And then the second value add I think is the people that we have. So I have a team of 25, like half PhDs, half industry experts that are like available to solve problems for the product team, make sure that we're building the right thing, and also to support like kind of our army of what we call applied data scientists who work with organizations who may have like a fledgling data science team or may need help getting buy-in or may need help just getting off the ground. So it's not just like, here's a platform and go fish. It's here's how we solve problems with this platform.
Right. From the product perspective over here, we find that having the data scientists in-house really helps us build a more correct product for our users. And we are able to really tailor our product towards data scientists.
Okay, thank you.